Perfect. All right. Hello, everyone. Welcome to the analysis meeting. I know it's been a while since we've had a live one, so hopefully we can get back on track, be on the same page, entering into spring semester. On the agenda for today, our check-in will just be a little bit about your winter break. Then I will talk about our spring schedule, what that's going to look like. And then we'll talk about tasks for our validation team and design team. On the validation side, as we were talking about earlier, rerunning the nose cone drag calculations at this point, just to have the documentation and data to justify a nose cone shape decision. And then two things that are closely linked, determining the fin shape and the fin flutter analysis. And then the design team talking about boat tail FEA and venturing out into the CFD. So how has everyone's winter break been so far? And are you ready for classes to start?
No.
What if?
Dang,
Classes every day now.
you were spoiled last semester.
I know, I only had classes Monday and Wednesday now. Every
Same.
single day.
I'm gonna have to start waking up at 5:30 to get to class on time,
Whew.
2 days a week.
And
You have an 8 a.m.?
Yeah,
Oh god.
I had no choice about it.
what
Yeah,
class?
that's the worst.
I don't even remember what it is. I just have it at 8
You
a.m.
just remember the time. I feel that.
Well, yeah, my winter break has been quite uneventful. I've spent a lot of time with family though, so that's been pretty good after staying on campus. And definitely not ready for classes to start. That'll be interesting and fun and quickly approaching. I think it's in 2
Yeah, a
weeks
little
from
bit
today, right?
It's
Or is it less?
it's
Or-
Less than 2 weeks.
Yeah,
12 days.
I think it's
Oh,
exactly 2 weeks.
Yeah.
Or I mean, not exactly 2 weeks.
yeah.
It's like 12 days, right? Because
It
we
is-
go back
it
on
is
a
12
Tuesday.
days.
Indeed.
Yep. Time for a hard ass semester. Omar, are y'all senior? Hold on one sec.
Yeah, but I have, I don't graduate till December. But I'm
Okay.
still technically a senior. You know, was also last semester.
I'm delaying graduation by 1 semester. So we'll see how that plays out.
When are you gonna do that? Right. Like when you gonna skip a semester?
No, I'm gonna like have the same semesters that we are planning to
Just
as
taking
well.
less.
Yeah.
Yeah, that's actually pretty smart. Okay, continue.
All right. For our spring schedule, we're going to remain with 1 online meeting and 2 lab meetings. The lab times, as usual, you're quote unquote required to make 1 and hopefully make the online meeting. Definitely don't expect you to come to both lab meetings, just there for your convenience. So the when to meets, the links are on the slide, and I'll also send it out in the Discord. Hopefully we can get those filled out and we can get a schedule down pretty soon. Also, with the fact that we're starting to order parts and get things physically into the lab, I guess it's good that Gustavo is here because I wanted analysis to get some hands-on work. And I know we haven't had any. And I guess if we stuck with our usual tasks of what we're doing, we wouldn't have any. But I think some hands-on stuff, maybe with specific sub-teams, would be very beneficial to other things we're doing. What are your thoughts on that, Gustavo?
I think anything hands-on is a fantastic thing to do. And the more we can do, the better.
Yeah, I think the good thing with analysis is that we often work with a lot of different sub-teams. So physically understanding the rocket and theoretically understanding it are 2 very different things from my experience. So hopefully we can get in the lab with some other sub teams and we can walk through their systems and hopefully help them out as well.
You know,
Moving on.
here's something else.
Mhm.
It might be redundant work, so only do it if you guys like have the time and like the will to do it.
Mhm.
But go ahead and make a scale model of the rocket. Make a
Oh,
yeah, just 3D print different sections like the nose cone, airframes, avionics bay, all that stuff, and make a scale model.
that idea. Ooh, so for our validation team, mainly Will on this, just re-updating these nose cone drag calculations with both the RockSim and OpenRocket data. Um, as I mentioned before the meeting, with our new 6-inch design, a tangent ogive nose cone was giving us, I think, around 2,000 to 3,000 more feet in apogee relative to a von Karman. And another reason I don't think von Karman will be as useful anymore is because we're switching to an O3400 with a 6-second burn time instead of the 2.5-second burn time of the N58. So the time spent in each subsonic, transonic, and supersonic regions will definitely change. And I think OGIVE may be the better performing out of all of our choices. And then making the necessary edits to the report. I know documentation has kind of fallen off ever since, I guess, after the PDR. We haven't really kept up with a lot of the changes we've made. But I think with this, it shouldn't be too bad just talking about the different simulations that we've ran for different designs, maybe some things that we've learned along the way. So Will, I'll help you out with the RockSim data and we should be able to get that done pretty quickly.
Okay.
So moving on to fin design, I know Gustavo, this is something you've been tinkering with on the new boat tail section and just modifying the fins and seeing what we can do to increase our apogee. But I think if we can give analysis and our validation team, specifically Mike and Amy, the chance to maybe come up with one of their own designs independently. I know Mike was working on her own simulations for trying to optimize a trapezoidal fin, but maybe now you guys can think more outside the box and try and get our 6-inch OpenRocket and RockSim files to 30K. And yeah, I think structures is okay with putting fins directly onto the end of the boat tail, if I'm not wrong. If there are any limitations with that manufacturability wise.
Yeah. There is some limitation, but it's a challenge that they're willing to take if it's the only way we can come up with. But on top of this design you have here, I guess there's 2 other things that I've come up with, and the basis for the designs is 1, not changing anything that's inside the rocket. So I know for this one that's right here, I think one of the things that needed to be done was shift the center of gravity further forward by putting the avionics bay in the nose cone, and then all the recovery stuff can go in between, well, avionics bay and payload bay. That's gonna take some more work in terms of figuring out how that's gonna all work out. So a big plus would be if we can come up with an idea that keeps anything from shifting around within the rocket. So just, I mean, in an ideal case, all you have to do is mess around with the fins. So 2 ideas I came up with are 1, making the fins attached directly to the constant diameter section of the airframe. So not the boat tail at all. That way, you know, you can use it as a MMM like we always have, or we have in the past at least. And then the boat tail is independent. You don't have to worry about the whole transition stuff. the only way I've been able to make that happen is playing around with the like a backward sweep, and it's not ideal because it makes it a little bit weirder to come up with like the fin flutter analysis and stuff, but it's still doable. And Randy's big suggestion in terms of fin sweeping back is make sure it doesn't sweep back past the motor, because one of the things you don't want is the fins to take the full impact of the landing.
Mhm.
I have a design up here that I'm playing around with, and I have a stability of 1.63, apogee of 29,900, and it's a 3-fin design. So I actually talked to Randy on my way home tonight, and he's suggesting looking at 3-fin designs because honestly, if we're gonna go through the process of making like this precision stuff, there's no reason we shouldn't be able to do 3-fin designs.
Mhm.
Um, the other idea is a lot like the one you have here on the screen, but it's a little bit longer and bigger, but it still gets you to the 30,000 feet and a stability of like 1.55.
Okay, cool. Are those open rockets on the drive?
No, but I can upload them. And I'm constantly tinkering with it, so it's never gonna
Right.
be like exactly the same. But I'll post basically what I have, so there's a reference.
Great. Thank
Wait,
you.
can you repeat what you said about what Randy told you about the fin sweep design? You said don't let them go past the motor? Or
Right.
what?
So fins can sweep. It's not like a like you're breaking some kind of rule to making your fin sweep backwards. Uh, actually, I'm gonna share my screen here for a second.
You should be able to.
Okay. Can y'all see?
Mhm.
Okay. So my fins sweep backwards. I don't know if this is gonna be too much and if like it's gonna flutter and like flap out of nowhere and destroy itself. But that's something I'll be figuring out soon. Um, the idea is your fins can sweep backwards to like add more like surface area behind further back to increase the stability. But the big problem is if your motor, I guess, was like any other rocket we've worked with before, and the motor was just like stopped at the end of the airframe, then now your fins are behind the motor. And so if it were to land, because it lands kind of like face just pointing up,
Vertically? Yeah.
yeah, the fins would take the brunt of the impact, and they could crack. And if they were to crack, then you lose a lot of points there in your flight performance. So yeah, the idea is they can sweep back, but a huge thing to consider is don't make them sweep back behind the end of the motor.
Gotcha.
Yeah. And then the other one I have, if you guys want to look at it,
Yep.
is this one. Played around a little bit, 1.55 and then 30,200. And the big perk here, I guess, is that everything stays how it has been designed thus far. So you don't have to go through the trouble of redesigning a whole bunch of stuff.
Mhm.
Another thing, like you said, Ravi, is the boat tail, like including the fins is a challenge. So if whoever decides to like work on it later, if you can come up with something that keeps it on the main airframe section, then that's ideal as well, more so than having it integral with the boat tail. Yeah. I'll
Mhm.
hand it back to you.
Thank you for that.
Wait, I have a question. What's the purpose of the boat tail?
So the boat tail, it's really just to reduce drag. How it works exactly is a little beyond me and
Yeah.
I guess the scope, but just adding a boat tail does a lot for reducing the drag. And it's kind of surprising how much it helps. some like
Really?
2,000, 3,000 feet in savings there.
I was reading about the boat tail and it talked about reducing base drag, which basically talks about as your rocket travels through the air and air is flowing around it, the bottom or the end of your rocket has a huge effect on like where the flow starts to return to normal, I guess. So I think it was talking about like the boat tail being much more conducive to that and decreasing some of the added drag you experience as if it was just like a kind of a flat cut as we were always.
Just looking at it, it looks more aerodynamic. So like, it makes sense.
Yeah, one of the things I guess I've seen before from like aerodynamic stuff is that if you have like a car or like a truck, like a semi truck, it's just like a flat back to most of it, right? The air will actually like curl back into the pocket that's like covered by that flat section. So because like there's nothing there and the rocket's going forward, the air will try to curl back in behind like the cutoff, I guess, or wherever there's no boat tail. That's a jumble of words. But I guess the boat tail just helps it transition back into like a reverse nose cone. So it slips through
Okay.
like a football, I guess.
Gotcha.
Yeah, so Mike and Amy, just keeping those points in mind. Open to 3 fins, so 3 or 4 fins are within the realm, and then trying to keep everything the same within the design, and just changing the fins, and preferably not venturing onto the boat tail. Although, if you do need to, I guess it is possible. So that brings us to the fin flutter analysis. It was relatively easy to calculate with our trapezoidal fin shape from Apogee Components and their newsletter with their equations. Most likely, I think with your fin design, you may find that non-trapezoidal or a free-form set of fins may perform better. So I think Randy recommending the Racero tool for fin flutter will be super helpful. But I know Montreal used, I think, 2 or 3 different ways and then compared results with those different formulas. I looked into some of them and some of them seem super complicated, and I honestly doubt if they genuinely did all the calculations, because it's a crazy amount of partial differential equations and matrices, all for calculating flow and drag and a bunch of nasty stuff. So I think I haven't taken a look at Racero's stuff yet, but that should be helpful. And I think kind of cross-checking as you move along with your fin design, what your fin flutter analysis or what your fin flutter velocity looks like, because it may take us to, or it may say on OpenRocket that we can get to 30,000, but if our fins are going to flutter, then there's no point in using that design, obviously. So kind of cross-checking as you move along in the design will be helpful and something you should do. Now shifting to the design team, I know the Oberon MMM FEA has taken up the whole first semester, unfortunately, but I think it's a good time to move past that, start fresh. And the main things I would want to gather from an FEA on the boat tail would be some stress points, and then also a thrust value or of force that we can say will start to cause deformation and failure. Unfortunately, I believe we're planning to manufacture the boat tail out of fiberglass, which, as we all know, is absolutely fun for FEA. So maybe simplifying and talking to Andrew again about how he could approach this, and also talking to Structures about their ideas for the motor retention system, and also how the fins will be secured, which I guess also plays into the fin design and when that gets finished up. But I think starting with the CAD of the boat tail and thinking about how our motor may be secured and how we can calculate, I guess, a thrust or a force value that will cause deformation failure. Should be good. And now onto CFD. I think I recorded this earlier as well, but just to restate, I think for the rest of the design team, I know the Zenith CAD is kind of up to date, minus the boat tail and the fins, which I guess are to be decided. So I think transitioning into CFD now will give us a lot of benefits, if not for this semester, definitely as SCR grows older and into the next year and years past. So from I would like us to use our learning FEA experience to hopefully help us transition into CFD much easier. And I think the three biggest ways in which we learned from FEA, and obviously everyone learns differently, but watching some YouTube videos about the software and kind of the goals that you're trying to achieve, and then finding learning resources outside of that. So I know for Siemens, there's a bunch of forums online where you made your account, and I think they also have their own set of videos and learning material within each software. And then also just beginning to research maybe outside of rocketry in general, look at what computational fluid dynamics is used for in the engineering world as a whole, and seeing how that can help the team specifically. So areas to analyze, I think most obviously the nose cone and the base drag with the boat tail, as we were talking about earlier, would be quite cool to, I guess, take a stab at initially. But I think the further goal that I would have with this is to ultimately aid SRAD propulsion in their designs, because I know Aussie was looking at using CFD to start to analyze how their motor and engine design could be optimized. So kind of just one for the future and one that will take a lot of time. But getting started as soon as possible, I think, is the best move for us as a team. So our action items, Will working on the nose cone drag calculations, and I'll help you out with the RockSim stuff. And after you, I guess, finish that up along with the report, moving on to helping Mike and Amy with the boat tail fin design and the fin flutter analysis, both of those kind of working in tandem, as I mentioned. And then with our design team, Arturo and Omar, the dynamic duo for FEA, working on the boat tail. And then Christian, Nikolai, and Jacob, I know, who were previously working hard on the Zenith CAD, and you guys have done a great job with that. But I think if you have an interest in doing some boat tail FEA or maybe some other FEA projects in general, definitely open to that, kind of up to you. But other than that, I think talking to other sub teams for help with CADing their systems, hopefully if we can save some of their time that they may spend CADing, we can all benefit and they can, I guess, start to advance on other things while we take care of the CAD for them. And then learning CFD and starting to gather those resources as well. And then just for everyone, reminder to fill out the new when to meets for the spring semester. And I'll send those links out on the Discord, and you can also find them in our meeting slides, in our slide deck. But any questions for anyone?
Yeah. When you mentioned the Montreal team looking at different, like, fin flutter tools and stuff, you mentioned that there's like PDEs and stuff. I know MATLAB has a PDE toolbox.
Yeah,
Um,
that's
it's not the easiest learning curve because I think I've tried to look at it before, but I mean, it could prove useful instead of like trying to calculate those with like an Excel file or something.
mhm. Yeah, I think we can look into that and see what values we can get, because I'm not sure what or how applicable those calculations were, because from the brief research I did, I know it was kind of like a stereotypical engineering class problem where you make a lot of assumptions that I'm not sure if you really can afford to make in the real world, and how accurate or what that difference is. But I think it's definitely worth a shot and something we'll look into.
Yeah, I was also gonna ask, I know this could be a little bit of a tough question to answer, but when do you think we would have a somewhat finalized design of the boat tail or just that area of the rocket, or even just the rocket in general?
I think the boat tail, the length of it and like design of it, it's like a straight taper from the 6-inch diameter down to a 4-inch diameter. I think it's like 6.5 inches long. I think that's gonna stay pretty much as is. I think they've played around with it. That's the optimum length. In terms of if the fins are gonna be on the airframe or the uh, transition piece, the boat tail, maybe by Wednesday next week should be the latest. Because honestly, we can't be spending any more time on that. But that's just a ballpark. I don't know for sure.
Yeah, I think it'll also depend on um, fin designs and whether we can find a fin shape to take us to 30K where the fins aren't on the boat tail. Because if they are, I think that'll affect um, kind of the makeup of the whole boat tail and how that impacts the.
Another thing that I saw that was really weird with Open Rocket, at least, whenever you set a when you try to make a set of fins that are on the airframe, it's simple. You just put them on the airframe. That's good. That's fine. But whenever you try to set it on a transition piece, there's no way to like make it go into the transition, right? If it's like set to the diameter of the outside of the rocket, so like the 6-inch diameter. So what you have to do is like on the transition piece, you add a section of airframe that is 0 inches long, and then you add the fins to that. And that lets you add the fins like on the 4-inch diameter section. So like they go back into the transition piece. But the problem is the tip of the what's it called? The fins also goes 4 inches in diameter. So the fins are technically, or the portion of the fins are technically inside the rocket still as well. So I'm not sure how Open Rocket is calculating that, because I tried setting like a 90-degree like out, kind of like a fin tab kind of design to the tip of one of the fins so it would match up with the 6-inch diameter, and then it has a taper back, and that gives me a different result than just leaving it as like a straight point, if that makes sense.
Could you
I'll show you
know what you're talking about?
because I think it'll be way too hard to show it in words.
Yeah.
Okay. So here's this fin design. It goes directly to wherever the tip of the fin is, right? So the tip of the fin is here and it goes back and then it has like this little fin tab. If I go to my other thing, this one, it goes for like I had to set a body tube that is 0 inches long, right? Just so I can add fins to it. And then so it's like kind of right there. And then you have the fins, but the fins technically go along the motor. This is the tip of the fin, not right here. But if I try to make a like,
Oh,
if I try to make a straight piece right there, so shape. Hold on. This is always so weird. Okay. If I try to go right here and add the thing, let's go right here. And then we'll, okay, that's weird. Right, something like that, to where it's like a tab and it comes up to the surface. It completely changes how it reacts. And then I lost like, I don't know, like 700 feet there.
Have you tried like starting out the fins on the like lower airframe at 6 inches and then changing its like position just to push it back onto the boat tail? Does that make sense?
I've tried. Oh, hold on. What I changed? This is not that one. Okay, this is a 30,000 foot. Okay, but it's still 4. Okay, I'll have to go back and change it. But I have tried adding the fins to like the 6-inch diameter and then making go back down, but it doesn't want to go further down than 0. So
Oh, really?
yeah, I'll open a new one. We'll add a nose cone, body tube, and the transition. After we'll just go down to like this, right? So let's say I want to put some fins onto this section, and
Mhm.
I want to make it go back this way. I can go right here and I can play around with like where different parts of the fins are. But let's go,
If you go to general,
right? I can't make a point below 0. Like I can drag it down, but it won't go below 0.
yeah, if you go to general and then position relative to, make that negative, like you just lower that or increase it.
It won't go below.
Mhm.
I mean, and I can add tabs as well, but I'm not sure tabs. I'm not sure tabs have aerodynamic effect.
Yeah, I don't know how it calculates each of that.
So I mean, I'm just commenting that I it's weird. I'm not sure how it affects anything. Or like if I go over here, if this is being calculated, like considering all of this, the fin, and not just the part that's external to the rocket.
Mm.
Because if that's the case, your center pressure is a lot lower. Or I mean, your stability is a lot lower.
Yeah, for what we're talking about, and I guess the physical challenges as well, I hope we can get a fin design without having to go onto the boat tail, because it seems like it's just complicating a lot. And I'm not sure if we could trust the open rocket with the different ways that we can put it onto the boat tail.
Can't you have it attached to the 6-inch diameter portion of the body tube and have it extend down but not attached to the boat tail?
You can't have it extend inwards at all. It won't go below 0. So when I pull up the,
It has like a flat, yeah.
when I go to the shape thing, I'm just gonna,
Yeah, but do you need it to go below 0? If you have it attached, it could just hang and be flat. I mean, I guess it's not parallel with the boat tail, but I don't know if that matters in terms of apogee.
so if I wanted to add another point, like let's say move this point outwards and then down below, I couldn't make it go below anything. I mean, in this case, I think it's, can I cancel that? I want to hit just like Control Z, but it doesn't let me. Is there an undo button? No. Oh, that's why. I got you. I'm on Mac, not Windows. I'm getting used to the computer at work. But right. It won't let, like, when you have a freeform like fin, it won't let you go below 0, and 0 is the diameter of the component you're building on.
Gotcha. But my point is, why does it need to go below 0? It can be
Because-
attached to the 6-inch diameter part, and then you just move it relative. Because
Because the
You want-
bottom of you want the bottom of the fin to be on the transitional piece,
Attached
not
to.
just hanging. Yeah.
Yeah. So in this case, if I wanted it to be right here and like go backwards, I want it to be attached. I want most of the fin to be attached to something, right? I mean,
I
I
got
guess technically I can just have this go like straight out, but I'm worried that it'll just flap around too much.
okay, I got you. I mean, yeah, and that design you have right now kind of eliminates the need for what you're trying to do, right? You just attach it to the 6-inch and have it. Or do you still want the end of it to hang to attach to the transitional piece?
This is the ideal case. Ideally, like it only attaches to the 6-inch airframe,
Yeah,
but it's not outside of the realm of possibility to have something, let's go this way, like this, where it can connect to the
yeah,
transition.
I got you.
Mhm.
I mean,
Makes it a lot more difficult.
yeah, the construction process or fabrication process just gets harder.
In terms of stability and apogee, which one do you think is better? Which type performs better?
I think probably if you can get onto the transition piece, it's better because you get the fins further back, which pushes your center pressure backwards, and you can use less fin doing it, so there's less drag.
Gotcha.
But it's hard to tell exactly because of, like the thing about this section here,
Yeah,
it changes the calculation. So I don't know if Open Rocket is using like the section of fin that's internal to also
yeah, you don't know how
act-
accurate it is, right?
Yeah.
Maybe I could probably play around with it and see if there's a loophole, but like knowing Open Rocket, I'm not quite sure there would be.
So Open Rocket actually has a PDF of like how they calculate literally everything, but I have not gone through it, so maybe it's worth
Yeah,
it.
it's dense.
Yeah, it's 127 pages of how they calculate every single component, and some of these calculations get pretty nasty, like this one. So yeah, it's just not fun to play around with. But oh, this is actually the part where it's saying how it does aerodynamics of fins, I think.
Hey Goose, I have a question.
Yeah, go ahead.
Why do you say that the manufacturing process is a bit more difficult than for the design that's on screen? Why is it harder than the other one?
So if I were to make this rocket, I make my set of fins and I can attach it directly to the rocket using what we've already done and are used to, which is an MMM, or we can just make it part of the rocket. That's fine. If we were to do something like this design, we would have to make the fins be part of the boat tail, right? And that's complicated because now we have this section that isn't uniform diameter. We have to make it part of this. The making a boat tail is already a challenge in and of itself. So the extra complexity is something we could theoretically manage, but we're in the blue. We don't know anything about it. And
But like, so I understand your point, but like the fins, the fin cord or fin tab would be essentially the same thing. Nothing changes. All you would do is add the slot on the boat tail for the fins.
yeah,
it would be the
but
same
now
thing.
in this case, now you have 4 sections of boat tail. if you do this, because the slot would have
Not-
to cut.
You don't, yeah, I mean, to eliminate that problem, you have, you cut like a slot on the fin so that it slides on the boat tail. Kind of like with Oberon's or my fins too. You cut like a section and instead of the fin going in the boat tail goes in the fin, if you know what I mean. Do you?
You're talking about just like a single slot for the fin to go into?
Oh shoot. Hmm. Yeah, like a single. Looking at this over like open rocket design, and I'm looking at that now. Like,
Yeah. See, I'm not saying that it's impossible, but I mean, kind
Well,
of the
it
thought
takes a
process
bit, I
you're running
think.
into right now is a thought process, I guess in time crunch mode we're trying to avoid. Because we're not saying that it's not doable, because it definitely is, but there's challenges with it, and if we can avoid having to deal with those challenges,
I mean, yeah. Okay. Because this one, I'm sorry, it's because like this one actually shows 30K instead of the other one 29, and I'm just kind of
Yeah.
pushing for that one, but it's up
this
to you.
this one I got to 30,000 a second ago.
Yeah.
With us.
Oh, you changed the fin
Yeah.
design, right? Yeah.
I mean, I'll play around with it some more, but essentially I had 30,200 with a stability of 1.66. But I had to undo it because
Yeah. Maybe that would
yeah,
be the
I mean,
best one.
the point is it's doable.
Yeah.
The question here is, does this sweep backwards cause problems in terms of fin flutter?
I would. Yeah, that's a good question. I would think so because it extends.
This is assuming we have a 3/8 inch thing, but if we do like a 1/4 inch, that tanks our apogee a little bit. I mean, I can't see it. I have to move this thing around 100 times.
Yeah, I went down like 1,000 feet.
Yeah.
Yeah.
So yeah, it just makes it difficult. And this is rounded. What if we do like airfoil? I mean,
What's airfoil?
Rounded at
That
the
would-
front, knife's edge at the back.
That went up 1,000 feet, 1,100.
Yeah. The problem when you come to like rounding and airfoiling is if you don't do it perfectly even on both sides of the fin, you can start inducing like lift, and so it'll start like rolling the rocket, like spinning
Yeah.
the rocket.
Yeah.
It is doable still though. It's just something to keep in mind.
Yep.
And honestly, we can do something like like a 1/5 of an inch. You get 30,000 exact. I mean, that stability is a little low. We can play around with that. But yeah, I mean, honestly, at this point, it's just tinkering around with it. I don't have to do that on a recording.
Yeah. I think you should change your material to fiberglass or carbon fiber.
What was the material?
I think it was cardboard.
Wait, what? I was wondering if
Yeah.
there was. Oh,
I mean, it adds a little bit of weight, but it should
craft
be-
phenolic.
Yeah, I mean, I just bring that point up because I think the weight will be
Yeah,
just
that's
to-
crucial.
for
Stability.
the gravity.
Material is crucial.
What if I go to where's carbon fiber? Should be towards the top. I mean, yeah. I don't know if you want to keep the recording going with this, but
It's worth it.
yeah, I'm gonna make this 8 inches, 8 inches. We got 1.5, which is good. We're low in terms of the apogee. what if we go back to? So this is another problem, I guess, if you guys want to like think about tackling this, is I'm just punching numbers in. I'm being a human computer and I'm just trial and erroring. I was trying to figure out if there's like a way to optimize this process. And the only thing I could really find is that there's like a rule of thumb that a 70-degree sweep is ideal. And so I punched a bunch of things into Excel to try to get a 70-degree sweep, but it's weird and it takes work. And I haven't done it yet, but if there's anything else that like could be used to optimize a fin rather than just like punching in different numbers and seeing what OpenRocket tells us, I think that'd be really good.
Yeah. Yeah, I think we'll end the recording here so we don't go too long.